Actually, the layer 2 boundary in most cases is a distribution layer, but if in some design maybe it is possible that we configure the access layer switch with the layer 3 interfaces, means routed interfaces, because an access layer switch in most cases don't support the for multi-layer switching or layer 3 ports. We use layer 2 links, okay, between the access layer and distribution layer, but it is possible in some design that we use layer 3 links between the access layer and also distribution layer. About the distribution layer, this layer aggregates the traffic from access layer and will distribute it into the rest of the network. This layer will usually have multiple switches and routers, in most cases layer 3 switch performing routing function, with each switch connecting to multiple devices in the access layer. As you can see, for example, here we have this distribution layer connected to multiple access layer switch, and also this distribution layer connected again to the access layer switch for redundancy. Here we have a link. This link can be layer 2 or layer 3. The distribution layer itself acts as a border, okay, creating self-contained network within the more extensive network. These distribution blocks can then route traffic to each other through the core layer. The advantage of separate blocks is that a problem in one block won't affect the rest of the network. Distribution blocks are where network policies should be applied and act as an additional layer of security between access layer and also the whole network. Here, as you can see, in the distribution layer, we have, for example, a point for aggregating the traffic of access layer switch, okay, and also this is the boundary between the layer 2 domain. Here we have layer 2 domain, and here we have layer 3 domain. This is the boundary between the layer 2 domain and layer 3 domain. About the layer 2, actually we can say in the side of layer 2, this is the boundary for a spanning tree protocol. In most cases we use one of the distribution switch as the primary root bridge and another as the secondary root bridge in STP, and actually it is limiting the propagation of layer 2 faults. These two feature, okay, boundary for STP and also limiting the propagation of layer 2 faults are occurring in the layer 2 side. In the layer 3 side with the core layer, this is a logical point to summarize IP routing information. You know that with summarizing the IP routing information or IP routing, okay, it can reduce the IP routing tables of the core layer switch for easier, for example, troubleshooting and reducing the resource usage in the core layer switch. After that, in most cases, we deploy the distribution layer switch in pairs for redundancy. One of the other functions of the distribution layer switch is reducing the number of fiber links between the, for example, multiple buildings. Okay, look at here. Assume that in the left building, in this picture, we have 3 switch, and also in the right building we have 3 switch. If you want to connect this switch directly to each other, you need, for example, multiple fiber links. But you can use distribution layer switch. Now with the distribution layer switch, we can aggregate the 3 access layer switch in one switch, and after that we need only, for example, 1 or 2 fiber link between 2 buildings. Actually, the function of distribution layer switch here is reducing the number of fiber optic runs between buildings. You know that this is reducing the cost of the network for us. The next layer is the core layer. The core layer is essential as it connects multiple network components and is made up of your highest speed, most powerful network devices. However, since it only has one purpose, it doesn't require too many features, just be fast. Okay, the core must be reliable and efficient to maximize performance, and also available at all times. It should be designed with redundancies so it doesn't have a single point of failure. If a catastrophic problem should occur, recovery needs to be quick. Okay, high speed switching is essential, as well as fault tolerance. The core layer should be scaled through quality, better equipment, rather than quantity, number of devices. Okay, CPU intensive packet manipulation, such as restrictive ACLs and QoS classification, should be avoided at this level. Essentially, the core layer should be as lean as possible to minimize the potential for failure and maximize efficiency. As you can see here, if you have more than 2 distribution layer switch, okay, and you want to connect this distribution layer switch together, for example, here in this scenario, we need many links, okay, but with a core layer, we can reduce the number of links. For example, here, we have 4 distribution layer switch, and we can use 2 core layer for redundancy. If we can connect the each distribution layer to a core layer, as you can see, to both of the core layer switch here. For example, this distribution layer switch connected to 2 core layer with layer 3 links, and after that, again here this distribution layer switch connected to 2 core layer, and so on. Because of that, about the core layer, the only things and the most important things that it is important for us is the speed and also the high availability and performance of the core layer. The core layer is the backbone and aggregation point for multiple network and provide scalability, high availability, and fast convergence to the network.